Hello everyone and happy Friday. It is time once again to do our studio review. We just finished up our first official studio of the semester, Studio 1, so I'm going to go ahead and hop right into it. You can see I've already got the studio code loaded up into Eclipse. Hopefully you're getting more used to that process by now. I know a few people are kind of still having some issues with getting things into Eclipse and GitHub and stuff like that. It will get easier, I promise. You're going to be doing it a lot this semester, so you'll get more familiar with the process. The instructions tell us to start with the Hi1 program, and we're just going to say hello to whatever name is supplied to us as input to our program. So let's go ahead and open up this program here. You can see that we've given you some code to start off with, including something that creates the scanner. A few people have asked me, if they need to understand exactly what's going on this line, and the answer is right now that no, not really, you don't. If you just want to think of this as the thing that creates the scanner, that's good enough for now. And later on this semester, we'll talk to you in a little bit more detail about what exactly is going on with this line of code. This is just a print statement that is going to ask the user to type something in, and excuse me, instead of this weird generic message, it might be better to say something like enter your name, so that the person using this program has a better idea of what it is that we're asking for. And then finally, this line, as I showed you in class, has the ability to take whatever is typed in and then store it in this variable called name. So your task then is to greet whatever person is using this program by saying hello to the value that is stored in this name variable. And in order to do this, we're going to need a print statement. And we'll start off by including what we want to say. So I want to say hello, and then I want to include the name here, right? But if I type name inside of the quotes, you'll see that it remains blue, meaning that it is going to be part of this string. It's not going to be referring to this variable name, which is what I'm actually trying to get at. I'm trying to get the contents of this variable and attach it to this string. So in order to do that, we have to use an operation called concatenation. So concatenation uses the addition operator, and we'll go ahead and add name, although it's more correctly stated as concatenating the name variable onto that string. And if we put a semicolon here on the end and try to run this program, we can hopefully get an idea of what is going to be happening here. I'll go ahead and type in my name, and then it says hello to me. And if I wanted to, I could add an additional message afterwards as well, right? The instructions indicate that I should say period, how are you? So I can include that as an additional, I can concatenate that additional piece of information on the end if I would like to. And so let's go ahead and try that again. This time you can see that I've sandwiched the name in between here, right? So whatever I type in is what's going to be used in that place in the text. And this is useful because now whenever somebody runs this program, I can use whatever they type in. I don't have to change the code every single time. That's a very useful thing to be able to do. Let's try and extend this out. Our next destination is the Hi4 class, and this time instead of just saying hello to one name, we're asking you to do it for 4 names. So I'm going to switch these up. I'm going to say first name, second name, third name, fourth name. And so, this time we're asking them to enter in names of people. And we want to say hello to all of them, but if you look at the instructions, you'll see that it's a little bit more complicated than that because when we have a list, we have to include commas. So we're asking you to make sure to include the commas in between the names for proper punctuation. So we're going to have to stitch all of those in using the variables as well as the punctuation and other text that we wish to include. But just like we saw with the last program, it's going to be a print statement. So I'll go ahead and say something like hello. And then after that, we can start including some of the names. So the first name is going to be in this variable called S0. So I'll say S0. And after that, I need a comma. So I can't just put the comma here, right? Because that comma is actually part of the text. And this is not. This is a variable name, so it contains text. But it is itself not text. It is a variable name. So this comma needs to be inside of quotes. But I can't just, do something like this, because now we're missing some information in between this variable name and this text. The computer's like, well, I can't just have these two things side by side. What do you want me to do with them? We need to be a little bit more clear and say, oh, we want to concatenate those things together. We want to stitch them together to make one bigger string. And then we can continue on by adding the additional names in a similar fashion. S2, comma, plus S3, and then when we get down to the final, one here, we don't want a comma, right? We would rather have probably a period instead. So we'll switch it up a little bit. Let's try it out. I'll use John, Paul, George, and Ringo for my names, and here we go. It says, hello, John, Paul, George, and Ringo. So now, instead of just one name, like our previous program, we have a program that can handle 4 names. It seems a bit more useful. However, right, you'll notice that it might be even more useful if I had a program that could handle any number of names that I want. So right now, if I want just one name, I have to use one program. If I want 4 names, I have to do another program. This program that we've been looking at can't do just one name, right? It can only do 4. What if I had a program that could adapt to however many names I wanted? If I wanted 1 name, it would just do the 1. If I wanted 4, it would do 4. If I wanted 10, it would do 10. That's an interesting idea, and one that that we're very interested in as computer scientists. We're going to kind of show you some techniques in the next few weeks here to help us do things exactly like that. But for now, let's return to the task at hand. We're asking you to take a second to think very quickly about what class and main method refer to in these programs. So I spoke about this briefly in class the other day. Spoke about these words up top as being kind of the magic words that our programs need to get started. You may have noticed that the class name is the same as the file name, and that's not an accident. That's very much on purpose. We'll also refer to this just as the name of the program. So every program in Java is going to be within a class, although not every class is a program necessarily. That'll make more sense later on in the semester. As far as the main method, I definitely remember speaking about this in class last week. The main method is our starting point. This is the point where we're telling the computer this is where our program should begin. So it knows that this is where it should start operating. Later on, as our programs get bigger and more complex, you'll see why we need to have a clear marker for this, because there'll be a lot more stuff in these files, and it may not always be immediately clear, so we have to go looking for that main method to understand where our program starts. Okay, let's move on to the next one, which is ordered. So this one, I like this problem because you know some of the stuff that you need to do this problem, but we kind of throw you a curveball. We actually ask you to use a new tool. So I asked you to do all that prep work, and then I pulled a little sneaky thing on you and said, well, wait a second, here's something new that you haven't seen yet. We'll actually see this in more formal detail next week, but I don't have a problem with introducing it to you now because this is actually very relevant experience. As you get farther and farther into computer science, you'll see that as computer scientists, one of the things that we need to be able to do is adapt and be able to learn new things as we go. And so this is sort of your first little taste, your first little experience of trying to do something like that. Here's the problem. We want to figure out, we've got 3 variables, and we want to figure out if they're in order, either all ascending, right? So they're all going up from smallest to largest, or all descending. They're all going down from largest to smallest. So if they're ordered, either all going up or all going down, I want to print out true. If they're not ordered, then I want to print out false. And so you can see the expressions that are listed out here to check. And one thing that I very commonly see with this program, here we go, we see values for x, y, and z are already provided for us. That's nice. One thing that I see, let's see, Boolean is ordered. This is what they wanted us to do here. To create a new Boolean variable, I might see people try to do things like x is greater than y is greater than z. And if I'm looking at this as a human being, this makes perfect sense to me. You've probably seen statements like this in your math classes. You can even find this statement right here on the website, right? The issue is that as the computer, we have to think about how the computer is going to analyze this, and it can only analyze, it can only compare two things at a time. So it's going to look at this and say, all right, is x greater than y? And that's going to be either true or false, right? It's going to be either yes or no. X is greater than y or it's not. And then it's going to say, let's assume that it is. Let's say that that's true. Then the next thing that it's going to do is say, all right, is true greater than z? And that's where we have a problem, right? That's where we have an issue, because true is a Boolean value and z is an integer. Those types matter. That's one of the big takeaways from this week's topic, is that the data types really matter a lot here. So when using these comparison operators, right, I can't mix and match those types like that. It has to make sense. True greater than z, what does that even mean? That doesn't make any sense. A way to phrase it that's more friendly to the computer, and a way the computer will understand, is to say that x must be greater than y and y must be greater than z. And that way we've taken this, chunk, this comparison, and broken it down into chunks of 2. Because that is how the computer must see things. And in order to accomplish, so we're trying to say x greater than y and y greater than z. But actually, this and word, we understand what that means in English, but that's why we included this section down here. Hopefully you took a look at this. We're going to look at this in a lot more detail later on next week, or maybe you talk to your TAs about it in studio, or maybe you talk to me about it. I talked to some people about it. But this is how we would include this in our code with the ampersands. So I'm going to swap this out for something like this. And that takes care of the situation for, where they're all, where x is greater than y and y is greater than z. And you could imagine that I could create a similar one for the opposite direction, right? So maybe instead of calling this is ordered, I'll use a few variables here. I'll say is ascending. I'm sorry, that would be descending. They're going down. Descending. And I'll create another Boolean variable for is ascending if all the values are going up. And it's going to look very similar to this. I'm just going to swap the signs, right? There we go. But what I'm looking for is not actually either one of these, but sort of both, right? I'm looking for this one or this one. So I want all of the, if all of the numbers are going down, then I want that to be true. And if all the numbers are going up, then I also want that to be true. Which leads us to the second logical operator, the OR operator. This key is one that you probably have not used on your keyboard a whole lot. This is called the pipe. It's just above the Enter key on your keyboard. So the way that we would use that, if I wanted to finish this up by saying is ordered, I could say is descending or is ascending. So if all of the values are going down, then yes, that's good for me. Or if all of the values are going up, that is also good for me. So if one of these is true, this will also be true. Is ordered will also be true. Only if both of them are false will this be false. And then finally, we'll go ahead and print this. Alrighty, let's test it out. Let's make sure that it works before we move on to the next problem here. We'll do 3, 4, and 5, and it says true. That's good. And we can also do 5, 4, 3. That's good. We should try one that doesn't work to make sure that it can properly detect those as well. So we'll do 2, 9, 1, false. There we go. Or if they're all equal, that should also be false, right? Because it has to be strictly greater than or strictly less than, not greater than or equal to. Although you could make that slight modification, I suppose, if you wanted to. Okay, let's move on to the next one. I think we have a couple more problems to go here. The next one that we're going to do is called average, and for this one we're not giving you any starter code. We're asking you to create this one yourself from scratch. So the way to do this is to right click on, this is called the package. That little brown icon looks like a package. So we're going to right click on the package, the Studio One package. We're going to select new class. Inside of here we'll type a name of our program / class. We're going to call it average. And then down here I usually want to click this box. There are some times when I may not want to check this box, but most of the time, especially early on, we're going to want to check this box. Everything else you can leave alone. You don't necessarily need to know or understand what this stuff is saying for now. We can just let the computer do what it's going to do. And you can see that we now have sort of a blank program here that we can use to do whatever we want. We're starting from scratch. So let's go take a look at the instructions now and see what our task is. We want to insert scanner code to accept two integers called n1 and n2. And we're asking you to go back to other code that we've seen before, and we give you some instructions about asking for a prompt. And then finally, once we get those integers, we want to average those two values together and print out the results. Okay, so first off, let's go back to the scanner. I'm just going to go back here, and you can see that we're going to go ahead and grab this line right here. This is, again, sort of the magic words that create the scanner for us. That's really the only line that I think that we need. I can go ahead and start including code to prompt for the integers next. So enter n1. And now I'm going to create a variable to hold the integer value that I'm expecting to read in. Integer n1 is equal to in dot. And now this is where things get a little bit different than what we've seen in some of the other programs. We've always used in dot next line, which reads in everything that was typed in as text. But we're dealing with numbers this time. We actually want numeric values. Specifically, we want integers. And so you'll notice that after I type dot here, Eclipse pulls up a list of all the things that we can use. And right here towards the top is one called next int. And that's what we want. That's actually what we're looking for. That'll read in the next value as an integer as opposed to text, which is what we want our program to do. If I was reading in a double, I could use next double, or next boolean would also be acceptable, right? So the scanner can be used to read in not just text, but any types that we might actually be interested in. And we're just going to duplicate this for n2. So I'll just copy paste that code and switch it all to say 2. Very straightforward. And now we're ready to compute the average. Pay attention to the fact that the result could be a double, right? So 5.5 is the average of 5 and 6. 5 and 6 are integers, but the result is actually a double. So we need to kind of take that into account. There's a few situations, a few ways we can deal with this situation. But first, let's take a look at what happens if we sort of forget to deal with that, or deal with it improperly, perhaps. Let's create a variable called average and do the simplest straightforward thing that I can think of, which is to say n1 divided by n2. I'm sorry, n1 plus n2 divided by 2. First off, we have to be careful with our order of operations, correct? So making sure that we put parentheses around here so that this addition happens before the division. We'll go ahead and print out the average value. And let's try our program. We'll use 5 and 6, and hopefully we'll get 5.5, but let's see. So what actually happened, I got 5 instead. So this is sort of the common mistake that people make when working with integers. n1 plus n2 is going to give me an integer, and this value 2 here is also an integer. So the types matter very much. An integer divided by an integer is going to be an integer. Even though the exact value is 5.5, the computer wants the type to be an integer, so it's going to throw that 0.5 away and just keep the 5. Just keep everything to the left of the decimal, which is what we're seeing here. You may be wondering, well, we called it a double over here. Shouldn't that fix the problem? And it's too late. Remember that we evaluate assignment statements going from right to left. So this actually happens before this variable, before that value gets stored into the variable. So it's already 5 before it gets put into this double variable. We have to fix it over here on the right side. And there's a couple ways we can do that. We just have to turn either the numerator or the denominator into a double somehow. We can turn the denominator into a double by putting a 0.0 on the end, like so. And so that will have the effect of retaining the double information. Or another way that we could do this is by casting. So if I include a double here out in front, that says, take the result of this computation and then turn it into a double. So when you see the name of a type inside of a parentheses, that is called a cast. It turns the numerator into a double, so that when I divide it by 2, it also will keep the result as a double and give us the more exact answer. Okay. I believe there is just one problem left to go for this studio, and it's actually one of the trickier ones, but we'll work through it step by step. We're going to write code to detect leap years. Okay? So leap years actually have more criteria than you might realize. Most people will know that leap years are in years that are divisible by 4. However, there's some other criteria listed here as well. So the number that's selected, it must not be divisible by 100. And then if it is divisible by 100, but it's also divisible by 400, then those years actually are leap years. So we give you some examples to try and clarify, right? 2020 was a leap year because that's divisible by 4. 1900 is divisible by 4, but it's also divisible by 100. So it is not a leap year because of this rule. And then finally, 2000 is divisible by 4 and 100. But since it's also divisible by 400, it actually is a leap year. So we have a few different things that we have to test. And actually, I think that what we can do is kind of keep these conditions separate and try to combine them together using some of these ands and ors that we saw earlier on in the studio. So let's give it a try. The first thing that I need to do is set up the scanner code to read in an integer that represents a year. So I'm going to go ahead and make a program and set up the scanner. Right click, go to new class. I'll call this one leap year. I'm going to check this box for the main method and click finish. I'm going to go back to my average code and grab the scanner code at the top. Paste that in. I'll change this to ask the user to enter a year, and I'll change this variable to say year as well. And now I believe we're ready to start actually detecting whether or not something is a leap year. So a lot of the things that we're checking for require determining whether something is evenly divisible or not. In order to accomplish this, we're going to use an operator called the modulus operator. So using division by itself, I think actually is doable, but modulus is a little bit simpler. Modulus provides us the remainder after division. So when we say something is evenly divisible, that just means that the remainder is 0. So let's see if we can start writing out some of these statements, starting with the first one. If I want to check to see if the year is evenly divisible by 4, right? So I'll say divisible by 4 equals year modulus 4. So that would take the year divided by 4 and then give me the remainder. So then I want to know if that remainder is equal to 0. It either is or it isn't. So I can say equals 0. And this code is actually a little bit tricky because, it looks kind of okay, but we've made a mistake, right? A couple mistakes. First, I need to say what the type of this is. Something is either divisible by 4 or it's not. So this is either going to be true or false. I think this is going to be a Boolean. All right, but even after I fix that statement, you can see it's still unhappy about this equal sign. Remember, a single equal sign is used to do variable assignment. I'm quite literally taking the value on the right-hand side and storing it in the variable that's described on the left-hand side. But what I'm trying to do here is not variable assignment, but rather a comparison. I'm asking if two numbers are equivalent to one another. Are they equal? And so that is not a single equals sign, but rather a double equals sign. That is the proper comparison. So this statement right here will do the trick for us. It's going to check to see if the year that was entered is divisible by 4 or not. Let's go ahead and make some variables for the other criteria. I think that's kind of the simplest way to approach this. So I'm going to make another one to see if it's not evenly divisible by 100. All right, so not divisible by 100 equals year modulus 100, and this time I want it to be not evenly divisible. So if modulus equal to 0 means that it is evenly divisible, modulus not equal to 0 would mean that it is not evenly divisible by 100. I believe we have one more condition left before we can try to tie it all together. We need to check to see if it is evenly divisible by 400. So let's by 400 year mod 400, and this time we are checking for if it is evenly divisible, so I'll say equals to 0. So these are the three conditions. You'll notice that we listed them this way on purpose. I very much am hoping that you kind of tried to break these out into separate variables. If you didn't, that's okay. It just probably would have made things look a little bit longer perhaps, but you could still do it that way. The last thing that we need to do though is stitch it all together. So something is a leap year if this is true and this is not true, as long as this is also not true. So we kind of have to stitch. Let me see if I can phrase that in a more easy to understand way. If something is evenly divisible by 400, then it is a leap year, right? Otherwise, it has to be evenly divisible by 4 and not divisible by 100. So if I want to specify that to the computer, is leap year is equal to, so if it's divisible by 400, then that is definitely a leap year, right? So if divisible by 400 is true, then is leap year should also be true. Or if it is divisible by 4 and not divisible by 100. So I'll say divisible by 4 and not divisible by 100. And in order to make sure that this is clear, I'm going to wrap this in parentheses. I probably made a typo there, huh? The same one that I've been making every time. That's a hard word for me to spell, apparently. Not divisible by 100. There we go. Fix my spelling mistakes here, and we can see that this is what I've ended up with. The leap year it's going to be a leap year if it is divisible by 400, or if it is divisible by 4 and it is not divisible by 100. So if it's divisible by, we can actually try it out, but if you want to kind of try and reason through it in your head, I think that's a good exercise as well, right? So if a value is divisible by 4 and it's divisible by 100, this would be true and this would be false. So true and false is going to be false. In order for this side to be true, both of these have to be true, right? So true and true gives me true, right? Let's try it out. Let me add a statement on here to print. And we'll try the examples that were given to us. So 2020 is definitely a leap year, right? It's divisible by 4. We said that 1900 is divisible by 4, but since it's also divisible by 100, it's actually not a leap year. So we see the word false get printed out. And then finally, the year 2000, right, even though it is divisible by 100 and 4 for that matter, it's also divisible by 400. So this one should be a leap year, and it in fact is. I think it's also important to test what might seem like an obvious case, but something that is not divisible by 4. What if it's not divisible by 4 at all? So 2023, very clearly not a leap year. Make sure that that works as well. And I think that'll do it. This is certainly not the only way to approach this problem, but I do think it's a pretty clear, straightforward path. You may have some issues with me using these really long variable names. I'm actually a fan of it. You might argue that it makes the text bigger and harder to read. I actually have the text zoomed in on my computer to help with teaching. When the text is at its normal size, these long variable names actually don't hurt that much, and I would argue make it easier to understand your code. That was another big concept of this week. Naming things is important, right? You can actually look at this and say this statement out loud because of the way that I've named these variables. And I mean, that's what I did just a moment ago. So naming your variables appropriately can really help you understand your code. If you're trying to code up something complex and difficult especially, make sure you name your variables appropriately. It'll help you understand things significantly. That's going to wrap it up for the studio for this week. The only other thing that I wanted to touch on real quick is the fact that your first homework assignment is due next week. So the grade calculator, you're going to write a program that's going to be able to be used to calculate your grade in the course. So you are asked to punch in the different parts of the course that are graded, and then compute the final course grade based on the weights that are given to you on Canvas. I'm going to let you read through all of the instructions on your own. I'm not going to sit here and go through it all now. What I do want to point your attention to, however, is that on Canvas, on the assignment 1 page, down at the bottom, is a rubric. So when you come to demo your assignment, which you can do either in office hours or in your lab section next week, when you sign up for demo, you're actually going to, your TA is going to go right through the rubric. They're going to start right at the top, and they're going to ask you these questions and start checking off the boxes. So you should have a pretty good idea when you come to turn in your assignment of what you're going to get. And you should definitely take a look at this rubric and, test your code. Make sure it can do all of these things. Make sure that it has all of the things that we're going to be looking for before you come to class, right? Do this all before you show up so that there's no surprises, no unexpected outcomes when you submit your homework. Okay, I believe that's going to do it for this week's studio review. Please let me know if you have any questions about the homework assignment or anything else. I'm available in office hours. You can make an appointment with me on Canvas. Otherwise, I hope you all have a great weekend, and I will see you in class on Monday.